Hello, it's Anne from morganmaths.com. Here's the first video from my One Nice Question revision series, and today the topic is trigonometric proof. I have chosen a lovely exam grade question from the excellent Mad as Math website. Some excellent resources there, really worth looking at as you are heading towards your revision. Pause the video, have a go at this question, and then the recorded solution comes just next. So how would I tackle that question? Well, the spirit here always needs to be, I'm not sure what I need to do, but I need to do something. So start by doing a bit of an inspection. On the left-hand side, you've got some trig functions of 2x. And you've got quite a few with just x. And the outcome of this proof is cosec x. So the first step that I'm going to take is to deal with these 2x because they shouldn't be there at the end. So let's start. And with those, by the way, you always start from whatever is given to you on the left-hand side, and then you prove what's on the right-hand side. Make sure you don't make one equals to the other and solve it like an equation, because that's not really a proof. You can't use the results to get to the results. That's not how the proofs work. Okay, so let's deal with these double angles. I'm going to still have my two fractions, and the denominator are going to be sine x and cos x, and cos 2x is cos squared x minus sine squared x. This is really an identity you ought to know. It's a formula you know to memorize. And the sine 2x, same again, it's one to know by heart. That's 2 sine x cos x. Okay, the 2x's are gone, but I'm far from the results. So I need to find something else to do. Well, if I have two fractions that I'm adding and different denominators, then I'm going to start by making the denominator the same. So I'm going to multiply the first fraction by cos x. I'm going to multiply the second fraction by sine x. Whatever I do to the top, I do the same to the bottom, and vice versa. So this means that now this cos squared x minus sine squared x is going to be multiplied by cos x. And I will have a denominator as sine x cos x. And the second fraction, I'm going to have 2. This sine x cos x needs to be multiplied by sine x. And all of that is going to be over sine x cos x. Am I nearer to the results? Not really. So I'm going to need to find something else to do. I'm going to merge the two fractions together. So the denominator is sine x cos x. And what do I have? Well, the only thing I can think of is to expand that bracket. So we're going to have cos cubed x minus sine squared x cos x plus 2 sine squared x cos x. Okay, nice, because I can now simplify those sine squared x cos x, because I've got 2 of them minus 1. So I'm now at cos cubed x plus 1 sine squared x cos x, all of that, over sine x cos x. And again here, it's a matter of thinking, right, what am I going to do next? When I see the denominator, you could be thinking, oh, that's quite similar to sine 2x. Not quite sine 2x, but it's not far off. Yes, but in the answer, you don't have sine 2x. So don't go there. The answer needs to be 1 over sine x. So what else could we do? Well, we could factorize cos x at the numerator. So let's do that. We now have cos x, and we are left in the bracket by cos squared x plus sine squared x. And that makes me quite happy because I recognize that this bit is 1. Anyway, so we then have at the denominator the sine x cos x. So what can I do with that? The cos x cancel. This part here of sine squared x plus cos squared x, this is equals to 1. So really I'm left with 1 over sine x. These trig identities take practice. They are quite hard to start with, but it's always a similar approach to them. So the more you have done, the more familiar you are, and the faster you're going to be doing such question. To find more question, I couldn't recommend more highly the work that Dr. Madas has left as a legacy on his website. So do visit his website. It's free, madasmaths.com. It's a really excellent place to find more question. Good luck!